Mr. Peters here. We're talking about factorable denominators today from lesson 101, which, when, said out loud, kind of sounds a little weird. Why are we factoring denominators? What's our approach here? Is this going to be difficult? The answer is no. This is simply finding common denominators so that we can either add or subtract regular fractions, right? Looking at these fractions, we've got some variables, we've got some trinomials, binomials. It'll be okay. It's really not that bad. So follow along, and you guys will have just a grand old time doing this stuff. Okay, so let's start off by doing exactly what this lesson wants us to do. We need to factor, right? So looking at this example here, I've got 6x over x squared minus x minus 12 minus p over x minus 4. I need to find that which is factorable, right? So let's factor this first denominator here, right? Let's factor this first denominator. Okay, so this is just a simple trinomial. So I'm going to have 6x over, well, let's see, when I factor x squared minus x minus 12, I'm going to take two x's. Since I'm dealing with a negative third term, I know I'm going to have plus minus, where the minus, right, the negative value is going to need to be larger than the positive. So two values that multiply together to give me negative 12, then add together to give me negative 1. That's going to be negative 4 and positive 3. Right, so I've got 6x over x plus 3 times x minus 4 minus p over x minus 4. Right? So we've done the first step, and that first step was just to factor what we could. And I want you guys to notice something kind of cool here, is that once we factored this, we see that there is something common between both denominators. Right? There is an x minus 4 in both of these denominators. So if I wanted to make my second term over here, if I wanted to make this have a common denominator with my first term, what do I need to multiply that second, right, this whole thing here, what do I need to multiply that by such that it isn't missing what is in this first term's denominator? Well, it's missing an x plus 3. So what I'm going to do is I'm going to multiply the top and the bottom by x plus 3. By doing this, I now have two terms that are like terms, right? Because they share that common denominator, right? I've got x minus 4. I got to make sure to put that in parentheses. X plus 3. Right, look. X plus 3, x minus 4. X plus 3, x minus 4. Once we have common denominators, all we need to do is combine, right? I can rewrite this all over that x minus 4, x plus 3. And what we usually want to do with these is you can re-multiply it out if you would like. I really only recommend re-multiplying it out if you know something's going to, combine in the numerator to cancel or something like that. But what we can do is we can just say, well, this is going to be 6x minus, right, this minus here is crucial. This is minus what's going on here. So I'm going to distribute that negative p throughout. So that gives me minus px minus 3p all over x minus 4, x plus 3. Right, so we found the common denominator, and then we were able to add those numerators together. All right, let's look at a practice problem from lesson 101. Okay, so the practice problem that I want to look at with you guys is practice problem A, and it says 9x is being divided by x squared minus 4x minus 21. And then we are subtracting 7 over x minus 7. Okay, first step when dealing with one of these problems, in your homework, this is simply just going to say, hey, add. That'll be your direction. Add what is given to you. So some of you may be thinking, I don't know how I'm supposed to add this. Just remember, what we need to do first is factor. So let's go ahead and factor this denominator. And I'll switch my colors up over here. So if we take x squared minus 4x minus 21, and we want to factor that, right? We have 9x in the numerator. I'm going to go x, and I've got a negative here, and a negative here, so I know I'm going to have negative, positive, where the negative is larger. Let's see, what two values can I multiply together to give me negative 21 that add to negative 4? Negative 7, positive 3, right? Negative 7 times 3 is negative 21. Negative 7 plus 3, negative 4, perfect. And we are subtracting 7 over x minus 7. Look at that, guys. We've got an x minus 7 in both denominators. That's just fantastic. So let's go ahead and take that which was common, or sorry, not common, the part that we're missing, and multiply the denominator and the numerator by that value, such that we have a common denominator. Okay, sweet. So let's go ahead and rewrite this problem. So we have 9x minus 7 times x plus 3 over, well, what would this look like if we were to multiply this out? That would just be this here. So we know that is going to be our common denominator. I'm going to write it out multiplied. X squared minus 4x minus 21. Now, for some of us, we might say, hey, this is it, right? I found my common denominator. I've rewritten my two numerators over that common denominator. I'm good to go. However, we look and see if I were to distribute this negative 7 throughout, I would have some like terms that I could reduce down. So I think that we should do that, right? Negative 7 times x gives me negative 7x. Negative 7 times 3 gives me negative 21. So what I really have is 9x minus 7x, which is just 2x, and negative 21, all over x squared minus 4x minus 21. That is a fully reduced, fully simplified fraction for us there. All right, I'm going to go ahead and do practice problem B as well. I'm going to do practice problem B as well because it's got a little extra stuff that we need to maybe look at. So we got 4. 4 is being divided by x squared minus 10x plus 9. And then we are subtracting 5 over x squared minus x. It's that second denominator that's going to cause us a little bit of trouble. Because normally we're going to look at this and think, hey, x squared minus 10x plus 9. I can factor that. That's easy. That's just going to be negative 9, negative 1, right? I can rewrite this as 4 over x minus 9 times x minus 1, right? Negative 9 times negative 1 is positive 9. Negative 9 plus negative 1 is negative 10. Sweet. And we're subtracting 5 over x squared minus x. Uh-oh. Do you guys see anything that is common between these denominators, right? If we look back at these previous problems, right, whenever we factored, there was always something that was common. There was always something that was common in those denominators. So looking at this, I don't see something that is common. Well, you know what we could do? We could factor this denominator, right? I see something that's common between both of these terms. So let's factor that guy out. Let's go ahead and do something like this. I want that blue again. There we go. Let's take this x squared minus x and factor out which is common. That's an x, right? When I factor out x, I'm left with x minus 1. So I really have x times x minus 1. Aha! Looky here. X minus 1, x minus 1. This is the sort of thing we want to try and find. We want to find things that are common. And now we can start multiplying both of these fractions by whatever the other one is missing, or whatever the other one has, sorry. Right, so I see that there's an x over here. And I'm going to do a little bit of this number for us. I see an x over here, so I want an x over here. Right? I need that x over here as well. Well, if I'm going to put it in this denominator, I need to put it in this numerator. There's an x minus 9 on this side, so I'm going to throw that x minus 9 over here as well. And remember, whenever you multiply a denominator or a numerator by some value, you need to multiply both denominator and numerator so as to not change the value of your original fraction. Okay, so now when I look through this, I see x minus 9, x minus 9, x minus 1, x minus 1, right? We have found the common denominator. And I'm not even going to multiply that out. I'm just going to rewrite this as 4x minus 5 times x minus 9 over x times x minus 1, x minus 9. That's fantastic. The numerator, though, can be reduced. I'm not going to change the denominator. I'm going to leave it. All right, so I'm going to go ahead and rewrite that denominator. I'm going to leave that one as is. And then I'm going to multiply out that numerator. So I've got 4x minus, well, that's going to be minus 5x and plus 45. So I've got a plus 45 and 4x minus 5x, which is negative x. There we go. There's our final answer. And if you wanted, like I said earlier, you could take this denominator here and multiply it out. Right? You could multiply this out. But you do not have to. It's perfectly fine to leave it as such. All right, so let me know if you guys have any questions. I've got nowhere else to be. All right.